Let's go to Leaker 962, maximal width ramp. So a ramp in array is defined a pair ij, I smaller than j, and nums I smaller equal to nums j. So the width of such ramp is j minus I. So give us an integer array, return the maximal ramp of this array. If no ramp, return 0. This question is almost the same as what we did before. We have a maximal length of semi-decreasing subarray, which we at that time we use an n log n time complexity way to do this question, right? And for that one, for this question, you see that the longest semi-decreasing is array that the first element is strictly greater than the last element. So find the length. So the difference is that this is the first one is strictly greater, right? And our ramp is smaller equal, right? And also this is the length of array, so that is j minus I plus 1. So the other conditions are all the same, right? For the 2863, what we do last time is we use an n log n way to do that. For this question, of course, we can also use n log n way to do it, right? So if we do n log n, is that our every number we create a pair that is a number and the index, right? Then we sort the number in ascending order. So if it is in ascending order, the later number, right, should always be greater equal to the previous number. And when we iterate the sorted list, right, so we can have a minimal previous index. And if, for example, we are at an index, and at this index, right, we can have, we know this number is greater equal to the previous one. We have this index minus the previous minimal index and compare with global result. And also after comparing, we update the previous index because this one may be smaller. So we can do similar way to like this. It is n log n. But this one, actually it has an ON time complexity approach. So let's talk about the ON time complexity approach. So let's look at these numbers, right? So the numbers, for example, it may have, for example, the nums 0, index 0, right? And in index 1, right? Index 1, index 2, for example, and index 3, right? And possible index 5, blah, blah, blah. 0, 1, 2, 3, 4, right? So we are looking for those kind of pairs. So assume we already the right, we already get the result. We have a pair ij, right? Or we call left, right. For example, we already find the right here. So in order us to find the left one, right? How can we select the left one? The left one, of course, the thing is that it should be smaller equal to right, right? And also we want the distance between left and right to be as big as we can. So let's look at these numbers. If nums 0 is one of the candidates, right? And let's look at nums 1. Well, see, nums 1 is greater than nums 0, right? So that means if we already selected the right number, for those number, if it can be form a pair with nums 1, it can also form the pair with num 0, right? Because num 0 is smaller than num 1. And also this num 1, you see, because the span is getting shorter, right? Because we moved one index to the right. So this one, of course, is not a good candidate because it's not optimal. So let's look at trying to select the left candidate. For num2, it is getting shorter, but uh, we'll see the number is getting smaller. So it is possible on its right, they may have some kind of number. For example, it is greater than number 2, but smaller than number 0, right? To have some kind of pair. So we cannot skip number 2. We should still keep number 2. The same way, we should keep number 3, right? And num 4. Well, see, num 4 is greater than num 3, right? That means only if we were to select the right number, if it is able to form a pair with this num 4, it can also be form a pair with num 3. So apparently, this num 4 is not our candidate. So in this case, what we're thinking about is that we can iterate these nums from left to right, right? And to find those kind of number which is strictly decreasing, and put those kind of index into our candidate array, right? So for example, 0, 2, 3, 5, right? So this is the left. And so for example, left 0, 2, and 3, and 5, right? If we already select those kind of candidate as our left candidate. So let's look at the right. So for the right, we iterate from the index n minus 1, right? So for example, the right is like this kind of height. So we'll see this file is able to form a pair, right? With these numbers n minus 1. If it is able to form a pair, that means um, every number between is 5 to n minus 1 if it's able to form a pair with nums 5, right? Will have the length smaller than nums n minus 1, right? So this will be shorter. So that means this nums 5 may not be used once it is able to form a pair with this right one. So we can pop this, right? And let's look at in this kind of our left candidate. Let's say this num3 is still smaller than nums n minus 1. That means we can still we can have this one and this one as a pair, right? So every time we are able to pop this. Every time before we pop, right, we have this kind of length compared with our global length. And then next round, we should go to nums2, right? We'll see nums2 is greater than nums n minus 1. Then we can, that means the longest pair end with n minus 1 can only be from 3 to n minus 1, right? So we trying to see what is n minus 2. For example, n minus 2 is here. Let's say n minus 2 is smaller, so it is smaller than 2, so we'll skip. For example, then let's look at, for example, there is n minus 3, right? Let's see, n minus 3, it is able to form the pair with a minus 3, 2, right? 2 with a minus 3 because it's taller. Then um, we have another candidate that is from 2 to a minus 3 and have this one to compare with global results. After we compare this, right? So we know every nonce between 2 to a minus 2, if they are able to form the pair, the distance will get shorter, right? So that means this nonce 2 will not use it anymore. So we can pop this. And um, we iterate from the right to left, right? And for example, if uh, um, it is possible, right? Possible that we still left something on the stack. For example, this one we didn't find a pair which is taller, right? But it's also possible that we pop out everything, right? So if every time we pop, we try to have this kind of length as a candidate with global value. So after this analysis, right, we can write code for this. So we know what we put is a strictly decreasing number from this nonce. And when we iterate from right to left, it is just popping the last element, right? So we can use a stack to simulate this process. We can also use a list, right? Because it is just remove last one. It is also a operation. So stack and the list both work. And we can also use index, interarray to simulate stack. So let's use a interarray to simulate a stack for this approach. We know int I equals nums dot length, and we are going to have int we call stack, right? Equals new int length. So we use an index to simulate the stack minus one, right? So initially, what we do is that we need to have a strictly decreasing number index put into index stack. So we'll say if this index equals minus one, or nums stack index is greater than nums I, then we're going to have stack index equals I, and the index um, will have index move index and have this first, right? So we can also write plus plus. So in this case, we put all of the index which have the strictly decreasing order, right? From zero. So what put will be zero, possibly nums three, three, which is smaller, strict smaller than num zero. For this, for this example one, right? It will put 0 and 1, right? Because after that 0, there is no one smaller than 0. And for this one, it will put 9, 0, 1, 2, 3, right? Put these numbers. Then what we do is that we iterate the index j, right? We have int result equals 0 for int I equals, that's still a minus 1. I greater equal to there I minus minus, right? So what we do is that while this kind of stack is not empty, and this nums stack index, the top one, right, is which is small equal to, if we are able to form a pair that is nums I, then we'll have result equals max dot max result would be I minus stack index, right? We should also this one move. We can also put this one here, right? In the end, we just return result. Python code will be very similar, and we can write Python. We'll have length, for example, n equals length is nums. And we have a stack. Use the list to simulate stack, right? For I in range, and if stack is not empty, right? Or nums stack, the last one, mm, greater than nums I. Then we're going to have a stack dot append I. Then we have result equals to 0 for I in range in minus one in a reverse order. So while this stack is not empty, and the nums stack, the last one, if it's able to form a pair, then we're going to have result equals to max result I minus stack dot top. In the end, we just return result. And for this code, actually, we are able to do almost the same thing with the code 2863, right? The thing is that we want to find the longest semi-decreasing. So that means we want to have this one will be the first element will be strictly greater than the last element, right? So that means when we can find a left candidate, that means on its right, we can only find the greater one, right? If we equal, because that's still not optimal as the left one. So as long as so if this one is smaller, then we can put that into the stack. And also, this one should be strict greater, right? Strict greater. And the result should, we are want to have the length plus one. Okay. So doing like this, these two, the time complexity will be O n, space will also O n, right?